Okay, well, we're going to go ahead and take a look now at a new set of definitions. These definitions are going to be kind of maybe a bit strange at first, and it might seem weird to see why in the world we would actually care about these particular definitions, but give it some time before you make too many quick judgments. Here's what we're going to have. We're going to have 3 definitions here in this box, so make sure you save enough room to have about 3 lines that are all about equally as long. So here's what we're going to have. Let's suppose that we have a series with a sub n, okay? For the moment, I'm going to leave off where n is going to start and stop, but let's just assume it starts at 1 and stops at infinity. But we're going to say that a series like this can be called something. We can give it an extra adjective. We'll call it absolutely convergent. This will be a blue title that will apply to this value. It'll be absolutely convergent if the series that looks almost exactly the same, but has absolute value bars around all the numbers in the addition problem, if that thing is convergent, then we call the original absolutely convergent. Okay, this is like super, super, super weird. Again, notice that we're just highlighting 2 different series. A series that says take all the numbers out of this list and just add them all together. I don't care whether they're positive or negative or zeros, it's totally irrelevant. But over here, we're going to say take all the numbers out of that same addition problem, make them all positive first, and then add them all together. And what we'll say is that if this series, once everything's been made positive, converges, then we'll say that the original series is absolutely convergent because it converges with absolute value bars. Notice that doesn't tell us anything right now about whether the original series over here actually does converge or diverge on its own. That we don't know. We're just saying if you slap bars on the series and you get convergent, you call the original guy absolutely convergent. Kind of a weird piece of terminology, but it's the first one we got here. Here's the second piece. We'll say that a series, a sub n, is called absolutely divergent if the series with absolute value bars on it is divergent. Okay, so I'm going to call this the red title. We'll say that the original series is absolutely divergent. It's red. If when you slap the bars on it, you get divergent. Okay, so we kind of have just separated this out. When you slap bars on the series, you either get convergent or divergent. That gives you one of these 2 labels. Here's going to be the final definition, though. A series, a sub n, is called conditionally convergent if it is not absolutely convergent. So another way to say that would be that it is absolutely divergent. So I'll say that it's conditionally convergent if it does not converge when you put bars on it. It diverges when you put bars on it. And it converges on its own. So I'm going to put this conditionally convergent title in green. Okay, so a lot of different titles here, and this is kind of strange. The last one is probably the weirdest one to keep straight in your head. So again, just as a recap, we'll say that a series gets this green title if it has the red title, if it's absolutely divergent, but by itself is just a regular problem before we even got to these definitions, it would have been regular old convergent on its own. Okay. If you take a look down here at example number 5, you'll see the types of questions that I'm going to ask related to these definitions. I'm going to ask for us to state with justification whether each of the series is absolutely convergent, that's blue, conditionally convergent, that's green, or just regular old divergent, which I'll call black. It's not even in the box above. It's just regular old generic black, okay? Divergent. So the red title's not really one of the options here. But we can go ahead and take a look really quickly before we even begin to answer these questions about at least what we could say is true about these different titles. Because something really interesting is going to be the case. We'll notice right away that some of these titles kind of exclude other titles. For example, is it ever possible that I could label a series with the blue title and with the green title at the same time? Think about the definitions. Pause the video if you need to for a moment to think about it. Well, if you've thought about it here for a bit, you might see that, wait a minute, in order to be a part of the green title, you need to have the red title. So if you're green, you're definitely also red. And if you're red, there's no way you can be blue. Those are opposite statements. So there's no way a series could have a blue title and a green title at the same time. And there's other sorts of restrictions that we have here. Notice, is there any way to have a green title and a black title at the same time? Pause the video again to try to think about it. Well, one thing you might see here again is that if a series is conditionally convergent, if it's got the green title, it has to converge all by itself. So could it diverge all by itself? No. So this green title and black title are also totally separate ideas. Okay. In the next video, we'll take a look at example number 5 and how we would actually begin to answer the questions that are listed there.